Previously in this course, we looked at the dispatch library, which features a number of tools that allow executing small tasks on either serial or concurrent queues. We noted that, whilst it's possible to execute tasks concurrently using the dispatch library, aggregating data calculated from these tasks is challenging. In this section, we'll look at another set of COCO asynchronous task management APIs that are much better suited to this kind of work: the Operation and Operation Queue APIs. Let's start by pointing out the similarities between these APIs. Both operations and dispatch have a queue type. For operations, this is called Operation Queue, versus dispatch queue in the dispatch library. One interesting point is that Operation Queue uses a dispatch queue internally, but builds on this with higher-level features. These queues can be used in either serial or concurrent modes, although Operation Queue provides more control over the number of concurrent operations in a queue at any one time. Furthermore, both have a task type that represents a job to be executed on a queue. Operations has the base class Operation, and Dispatch has the class Dispatch Work Item. However, as we saw in the previous section, it's more common to execute simple closures on a dispatch queue, since this better suits the common use cases for dispatch. So then, given the similarities, what are the advantages that Operations offers over dispatch? First of all, Operations provides a fully object-oriented API. This allows us to associate data with our tasks, the results of the tasks, as well as any data that is a requirement for starting a task. Operation Queue provides a simple feature to control the maximum number of tasks that execute on a queue, which can be convenient in many use cases. An extremely powerful feature of Operations, if used effectively, is the ability to associate dependency operations with operations themselves. We'll detail this shortly, but in summary, this allows you to compose operations together, creating larger operations from small and focused sub-operations. This can result in tidy and modular code. In order to support this, operations manage their own internal state. Operations go through various transitions from being created, ready to execute, executing, finished, etc. Finally, it's also possible to set priorities between operations in queues, another example of the finer grained control we have with operations. So, having noted these extra features, what are some of the drawbacks to using the Operations APIs? Overall, operations are somewhat more heavyweight than dispatch, but this is partly in the design. We need to create a subclass of operation, whereas we commonly just execute closures on a dispatch queue. This does, of course, have the advantage of associating data with our operations, but makes operations a bad choice for simple one-shot tasks. A major disadvantage, and the focus for the second half of this section, is the inconvenience of working with the operation base class. Managing operations' internal state machine can be quite hard to learn, and especially for Swift developers with no experience of Objective-C. This is because operations are built around the legacy Objective-C paradigm of key-value observing. We discussed this programming style in my previous course, Exploring Swift. In spite of this, with the use of some helper code, operations can be adapted to be an extremely powerful tool, and we'll be looking at this during this section. Given that we've discussed the advantages and disadvantages of operations and dispatch, what are some simple rules you can use to help to decide which to use? Dispatch is best suited to small blocks of code, particularly when they have no complicated dependencies other than perhaps capturing values from their surrounding scope, as is the nature of using closures. We also noted in the previous section on dispatch that dispatch has some powerful uses as an alternative to using locks when using a serial dispatch queue to protect a shared data structure. On the other hand, operations are much better suited to reusable chunks of work, in particular data processing. You might, for example, create an operation that processes a type of file and then want to repeat this operation many times on a set of files. Operations are ideal for this. Also, due to their ability to be composed together using dependencies, operations have the great strength that large and complex tasks can be broken down into discrete steps that can be developed and tested separately. These smaller operations can even be composed into other larger operations, if well designed.